morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about priority interrupt. So, in the priority interrupt, the data transfer between the CPU and an input-output device is initiated by the CPU. The CPU cannot start the transfer unless the device is ready to communicate with CPU. The read lines of the device can be determined from an interrupt signal. Numbers of input-output devices are attached to the computer. Several sources will request service simultaneously. The first task of the interrupt system is to identify the source of the interrupt and decide which device to service first. A priority interrupt is a system to determine which interrupt is to be served first when two or more requests are made simultaneously. Also determines which interrupts are permitted to interrupt the computer while another is being serviced. Higher priority interrupts can make a request while servicing a lower priority interrupt. So, one or more programs are there. Programs have to be generated, then priority should become. If priority is that nothing but we are going for the interrupt. So priority means highest priority. So when we are going for the highest priority, which one is the highest to execute that one? So there are so many are there: interrupt 0, interrupt 1, INT 1, INT 2, like this. So there are so many interrupts are there. Which one is the highest priority? There is which one is the highest priority? We are taking as a trap. Highest priority is called trap. So here so many interrupts will be there. So what is the highest priority? I am taking as trap. So trap is nothing but the highest priority in that. So the data transfer between the CPU and an input-output device is initiated by the CPU. The CPU cannot start the transfer unless the device is ready to communicate with the CPU. The read lines of the device can be determined from an interrupt signal. So when the interrupt signal is come from the CPU, then we have to stop that program, and what is the previous program that will be continue. That is the interrupt signal. And number of input-output devices are attached to the computer. Several sources will request service simultaneously. The first task of the interrupt system is to identify the source of the interrupt and decide which device to service first. So if I am going for the input-output is that, then what is the input-output? Priority is selection. So which one is the priority? First one, selection. Okay. So CPU priority is different and input-output is different. When number of input devices are attached to the computer, so these attached to the CPU or computer, then which one is the first enabled? How much? What is that then? It is going for the priority. When priority we should become number of inputs or outputs. Number of inputs or outputs. A priority interrupt is a system to determine which interrupt is to be served first when two or more requests are made simultaneously. Also determines which interrupts are permitted to interrupt the computer while another is being serviced. Highest priority interrupt can make a request while servicing a lower priority interrupt. So first we are going for the highest priority, then only going for the lowest priority. So a priority interrupt is a system to determine which interrupt is to be serviced. So I have suppose INT 0, INT 1, INT 2. So which interrupt we have to be served first. So what is the highest priority? That is I am calling as a trap. Trap is nothing but a highest priority in that, and is to be served first when two or more requests are made simultaneously. Maybe we are getting two or more requests maybe coming simultaneously, but highest priority and lowest priority we have to select. And also determines which interrupts are permitted to interrupt the computer while another is being serviced. Higher priority interrupts can make requests while servicing lower priority interrupt. So establishing the priority of simultaneous interrupts can be done by the software or hardware. So when I'm going for the interrupt, maybe it is a software interrupt or hardware interrupt. So we are establishing the priority of simultaneous interrupts can be done in the software or hardware. The priority interrupt by software, that is a polling. So we are calling as a software priority, we are calling as a polling. So priority is established by the order of polling the devices, that is interrupt sources. So flexible since it is established by software. Low cost since it needs a very little hardware, very slow. So when it is going to the priority is established by the order of polling the device interrupt sources. Flexible since it is established by a software. So in the computer we have software getting problem and hardware also getting problem. So in the software interrupt we need or hardware interrupt we need. How can we find out? So when we are need a software interrupt, that is calling polling. So this is established by the order of polling the device, that is the interrupt sources. So what are the interrupt sources to stop the software? And flexible since it is established by software. And low cost since it needs a very little hardware and it is very slow. So when I'm going for the lowest priority, the flexible since it is an established software, and the low cost since it needs a very little hardware. When a less hardware I need, that means it is a low cost. When I need high potential hardware, then it is a high cost. So what are the drawbacks of polling? CPU takes more time to check which device has to generate the interrupt signal, but it takes less time to execute the corresponding ISR program. So CPU takes which much take the time. But why? Because the device has generated the interrupt signal, but it takes less time to execute the corresponding ISR program. So when you are going for this device, it checks the device has generated the interrupt signal. Already interrupt signal is generated, but how much process is getting that one? How much time it is consuming to getting the interrupt? So this interrupt signal takes less time to execute the corresponding ISR program. So highest priority we are calling as a trap example. Lowest priority is there. So when I am going for the priorities are two types. Priority interrupt, software initiated interrupt, hardware initiated interrupt. So when it is going for the, suppose I need low hardware device, I need low hardware. High hardware requirement, that is high cost. So the priority interrupt by hardware, daisy chaining and parallel priority encoder. So when I'm going for the hardware priority, that is a daisy chaining and a parallel priority. So here I'm going for the software interrupt, that is a polling, and here I'm taking the hardware means daisy chaining and parallel priority. Requires a priority interrupt manager which accepts all the interrupt requests to determine the highest priority request. First, since identification of the highest priority interrupt request is identified by the hardware, each interrupt source has its own interrupt vector to access directly to its own service routine. The hardware priority function can be established by either a serial or a parallel connection of interrupt lines. The serial connection is also known as the daisy chaining method. So it is about the priority is about the hardware. So how the interrupt manager which accepts all the interrupt requires to determine the highest priority request. To identification of highest priority interrupt, request is identified by the hardware, each interrupt source has its own interrupt vector to access directly to its own service routine. So every interrupt has its own interrupt priority to getting this one. It is a service routine. The hardware priority function can establish by either serial or a parallel connection of interrupt lines. The serial connection is also known as daisy chaining method. So serial connection of the hardware. Serial connection of the hardware interrupt is called daisy chaining method. So daisy chaining priority. Daisy chaining priority method of establishing priority consists of a serial connection of all devices that request an interrupt. The device with the highest priority is placed in the first position, followed by the lower priority devices up to the device with the lowest priority, which is placed last in the chain. So daisy chaining priority is a hardware priority. This method to establish the priority consists of a serial connection of a device. Okay, serial connection interrupt. The device with the highest priority is placed in the first position. So what is the highest priority and taking as the first position, followed by the lower priority devices. So first highest, after the lowest, with the lowest priority which is placed in the chain. So here I'm taking, there are multiple devices are there. Here I'm taking input output devices are 3. I'm taking sample. So devices with programming input, program output, program input, program output, input and output. So I'm taking here device 1, device 2 and device 3. Okay, these are connected to the processor data bus. So if interrupt daisy chain priority means interrupt request. So multiple devices are there. So which one have to be connected to the CPU first? So there are 3 devices are waiting to the CPU. So which one is the first connection? So where there are so many devices are waiting for CPU connection, that enable means priority should be come. So which one is the highest needed, highest priority? Suppose device 1 is the highest priority. So then I am going for the trap device 1. Then highest priority of this one, device 1 will be enabled. So this is the highest priority is placed in the first position, and the lowest priority device up to the device with the lowest priority which is placed in last. So first which one is connected, that is the highest priority, and the last which one device is connected, that is the lowest priority is placed in the chain. So these are the 3 devices are connecting as the processor data bus. Okay, and we have the interrupt request. When interrupt will be should come means there are multiple devices are there. So interrupt 1, interrupt 2 or interrupt 3, 3 interrupts are there. So when multiple devices are waiting, interrupt is also there. So we are giving the interrupt request to the CPU. CPU will priority, first one is it will be decide and will give the acknowledgement to the input output, and it will be enabling the which one is highest priority, it will be enable. So it is a interrupt. CPU will give the interrupt, and which one is first priority, that is called the interrupt acknowledgement to the device 1. Suppose device 2 or device 3. So suppose here device 1 is the highest priority. So it will give the interrupt acknowledgement to this one. That means the highest priority of the device 1. So after then acknowledgement means device 2, device 3, like this. Okay, interrupt request it will accept the CPU, and interrupt acknowledgement it will give to the devices. So interrupt. So here so there are device was one there. So when I'm going with the device 1, interrupt, we are giving the interrupt to this one. So suppose CPU has to give the device 2, that is the INT acknowledgement, it will give to the device 2. So it is the highest priority, remaining are the lowest. So parallel priority interrupt. The parallel priority interrupt method uses a register whose bits are set separately by the interrupt signal from each device. Priority is established according to the position of the bits in the register. In addition to the interrupt register, the circuit may include a mask register whose purpose is to control the status of each interrupt request. The mask register can be programmed a disable lower priority interrupts while a higher priority device is being serviced, and it can also provide a facility that allows higher priority device to interrupt the CPU while a lowest priority device to be serviced. So how where parallel priority should be connected to the interrupt. The parallel interrupt method uses the register whose bits are separated with the interrupt signal from each device. So what are the devices are there? Each device we have to connect. So suppose I have to three devices I have to connect parallelly. Okay, is it possible? Yes, it is possible with interrupt. And priority is established according to the position of the bits in the register. And in addition to the interrupt register, the circuit may include a mask register whose purpose is to control the status of the each interrupt request. So there are so many requests should be come to the CPU. So we have to control the which devices to which one is a priority should become, and mask should manage or should control the status of the each interrupt request. And the mask register can be programmed to disable lower priority interrupts while higher priority device is to be being serviced. So mask will identify which one is the highest priority. It will be decide and will be connected to that device. And which one is the lowest priority, it will be connected to the lower, means last priority, and allow lower priority device to be serviced. So the priority logic for a system for 4 interrupt sources is shown given. So here I am giving interrupt register, disk is the first one connected, printer, reader and keyboard. How many are there? There are 4 devices are connected, 1, 2, 3, 4 devices are connected, and the mask register is a 0, 1, 2, 3, means 4 are waiting mask. So which one is the highest, which one is the lowest we have to do. So here disk 1 connected to this one. Okay, mask is connected to disk. Then it will be enabled. Suppose 1 is enabled means printer will be enabled. Suppose 2 is enabled means reader. Key 3 means keyboard will be enabled. So there are multiple inputs are waiting, and the mask will be select which one is the highest priority and which one is the lowest priority. Here I0, I1, I2, I3 means input 0, input 1, input 2, input 3. So total 4 inputs are there. Here how many bus buffers are there? 1, 2, 3, 4, 5, 6, 7, 8. So it is a CPU out. Interrupt to CPU, interrupt acknowledge from CPU. So there are so many devices are there. These devices are giving the acknowledgement interrupt request to the CPU, and CPU will give the acknowledgement to that devices. And it is a priority encoder with a truth table. Here I am taking 4 inputs, I0, I1, I2, I3. So I am taking I0 equal to 1, remaining are constant. So what is about the output is 0, 0, 1. If I am taking this one is 1, so 1, 1. This one is 1, 1, 0, 1. And this one is 1, 1, 1, 1. So x equal to I0 dash into I1 dash, y equal to I0 dash into I1 plus I2 dash into I2 dash. So highest equal to I0 plus I1 plus I2 plus I3. So it is a Boolean function with inputs and outputs. So these are the references. So we discussed priority interrupt. So in the priority interrupt, the data transfer between the CPU and input output device is initiated by the CPU. So when the priority should become means multitasking or multi-programmings are there, or multiple inputs outputs are waiting at CPU. So number of input output devices are connected to CPU, then input output to CPU, it is a interrupt, and CPU will give the interrupt acknowledgement to that one. So number of input output devices are attached to the computer, several sources, and will request service simultaneously. The first task of the interrupt system is to identify the sources of the interrupt and decide which device to serve first. So a priority interrupt means which one is the highest priority we have to give and which one is the lowest priority we have to give, and it will be decided by the interrupt. So the priority interrupt by software, that is the polling. So the priority is established by the order of polling device, that is the interrupt sources. It is established by the software. So software interrupt we are calling as a polling. And if low cost needs very little hardware, so when we are going for the low cost of this polling, we need low or little hardware we need, and it is somewhat very slow. Why? Because I'm using little hardware with low cost of softwares, so I'm getting very slow. So what are the drawbacks of polling means? CPU takes more time to check whether device has to generate interrupt signal. So that is a disadvantage to execute the program. And priority with interrupt by hardware, that is a daisy chaining or parallel priority. When we are going for the priority interrupt with manager, which accepts the interrupt request to determine the highest priority. So I need first what is the highest priority I need, then only you will go for the lowest priority. And the hardware priority function can be established by either a serial or a parallel connection of interrupt lines. The serial connection is also known as a daisy chaining. So the data transfer with a serial connection I'm taking as a daisy chaining. Daisy chaining is a serial and it is a parallel. Parallel priority, serial priority. So daisy chaining is nothing but a, when I'm going for the data is in a serial mode, not a parallel, serial one by one. Okay. So parallel priority. So parallelly we have to connect it to the CPU. And it is a parallel connections, disk, printer, reader, keyboard at a time parallelly connected to the CPU. And priority encoder means we have to priority, highest priority, I0, I1, I2, I3 of the input, and we are getting the output from the CPU. So if interrupt is enabled, then we are getting the request from the devices to the interrupt to CPU, and the CPU will give the acknowledgement, that is a int acknowledgement from the CPU. And it is a truth table of priority encoder from input and outputs. So here I am taking four inputs and 2 outputs, and 0, 0, 0, 1, 1, 0, 1, 1. Here step size like it is an input and output, and it is a boolean function x equal to I0 complement with I1 complement, y equal to I0 complement into I1 plus I2 complement into I0 complement. So it is the final result of IEST equal to I0 plus I1 plus I2 plus I3. It is about the priority interrupt. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.